Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is F-5, Applications of Functions. We'll start by taking a look at question number 4. It says Kevin saves the same amount of money each month in his savings account. The amounts of the money he saved after different numbers of months are shown in the following table. And we're going to need to determine the rate of change and the initial value for this function. Okay, let's start off by talking about these terms, rate of change and initial value. Rate of change is also the slope. So when you hear rate of change, you should be thinking slope. And initial value is also similar to another term that we've used quite often, y-intercept. Alright, so to determine the rate of change or the slope of this table, we need to figure out the change in the value of x and the change in the value of y. So to go from 4 to 6 and 6 to 8 and 8 to 10, you should see that we're looking at a gain of positive 2 each time. And remember, this is months of savings, x, so this looks like we're skipping every other month. So we're looking at the 4th month, skip 5th month, we're looking at the 6th, skip the 7th, we're looking at the 8th, skip the 9th, we're looking at the 10th. And then we're looking at the amount of money that was put in. So on the 4th month, he had $1,100, and then at the 6th month, he had $1,400, which is a gain of $300. The 8th month, he had $1,700, another gain of $300, and in the 10th month, $2,000. Another gain of $300. So now I need to think about the change in y over the change in x, and as you can see, that works out to be 300 over 2, which breaks down to 150 over 1, or 150. So my rate of change, or my slope, is 150. Now, it's interesting, as a rate of change, we can show it as 150. As a slope, we would generally want to show it as 150 over 1. So there's a slight difference in the interpretation of rate of change versus slope. Otherwise, they're pretty similar. Now we'll look at the initial value. In order to determine the initial value, you should remember that you need x to be at a value of 0 to determine what y would be, and y's value is your initial value, or your y-intercept. So what I've noticed here is that we're jumping by 2-month chunks, and we could continue to do that to get to 0, or we could work by 1-month chunks, which is what I've chosen to do to help illustrate a little easier what's going on. So I've created this table if it were to continue up higher, but I'm doing it in 1-month intervals so that we can better see exactly where we'll be. So at 3 months, we would have been at $950. At 2 months, we're at $800. At 1 month, we're at $650, and at 0 months, the total amount in his bank account would have been $500. So our initial value is $500. And because this is a word problem, we need to kind of make sense of these numbers. What does 150 mean as a rate of change when you think about this problem? What does 500 mean as an initial value when you think about this problem? So a rate of change of 150 indicates that Kevin is saving $150 per month into this savings account. What does it mean to have an initial value of 500? That might seem odd. Why at 0, you might think that the total amount of money here would have been 0, but it wasn't. So how does that work out? Well, an initial value of 500 simply means that Kevin opened his bank account with $500. So when he created the bank account, he put 500 in, and then from that point on, he's been putting $150 in each month. Alright, let's take a look at question number 5. Question number 5 states that a shipping company uses this graph to show its customers the cost of sending a package based on the weight of the package being sent. Again, we need to determine the rate of change, or the slope, and the initial value, or the y-intercept, for that function. So if we look at this, we can see that we are starting at 2, and then we jump to in between 4 and 6. So you should see that that's where 5 would be. So I've indicated it here on this graph. You can see 5 falls between 4 and 6, and that's where the next point is on this graph. And then we jump to right above 4. And if you think about what the rate of change is from each of these points, starting at 2, to get to the next point on this graph, you would have to go up 3 to 5, and then over 2 that way. So this you should recognize this as the rate of change or the slope. And so that's going to be y over x, y being this side, our cost, and x always being the horizontal line. So we're looking at a rate of change of 3 over 2. And now we want to look at what our initial value is. Well, at 0, we're starting at 2. So that indicates that our initial value is 2. So if we take a look at this as a rate of change, you can see that if we look at the change in y and the change of x, we have $3 over 2 pounds. And that can actually be reduced to $1.50 for 1 pound. Now we can work with this as 3 over 2, or we can work with this as 150 over 1. It really doesn't change how the outcome would be. So if we explain what the rate of change means for this scenario, it simply means that a rate of change means that for every 1 pound, the price is $1.50. Looking at it this way, for every 3 pounds, or for every 2 pounds, the price is $3. Explain what the initial value means for this scenario. Well, in this case, the initial value simply indicates that the minimum is $2. So regardless of how light your package is, if it's under 1 pound, you're going to pay a minimum of $2. Now, if you think about this as a graph, you'll notice that it doesn't extend to this side of the graph or down here to this part of the graph. So we're only in the positive quadrant. And why would that be? Why doesn't this graph extend to the left of the y-axis or below the x-axis? Well, the answer to that would be the graph does not extend to the left of the y-axis or below the x-axis because you can't have a negative value for a weight or for a price. If the graph was extended to the left, what would be the equation of this linear function? So the equation of this linear function would be, of course, we're using y equals mx plus b form for a linear function. So we would then have to plug in the slope, which I'm using 3 over 2. You could use 150 over 1. You would get 3 over 2 for m, and then we know that our initial value, or y-intercept, which is the value of b, is a 2. So you could write y equals 3 over 2x plus 2, or you could write y equals 1.50x plus 2. Either one of those answers would be correct. And if a package weighed 40 pounds, what would be the cost to send the package? Well, taking the y equals 3 over 2x plus 2 and substituting 40 pounds for x, we get y equals 3 over 2 times 40 plus 2. Now, these would cancel out, so the 2 would cancel out, and the 40 would become 20. So that's going to leave us with y equals 3 times 20 plus 2, which then breaks down to y equals 60 plus 2, or y equals 62. So that tells us that the cost of sending a package that weighs 40 pounds would be $62. And the last question we're going to take a look at is question number 7. Relate and compare the terms slope and rate of change and y-intercept and initial value. And we talked about this a little bit in question number 4. The terms slope and rate of change are both referring to the same thing, but we tend to use the term slope when we are working with an equation or a graph. We tend to use the term rate of change when we are working with real-world scenarios. Same thing for the y-intercept. The terms y-intercept and initial value, both referring to the same thing. We tend to use the term y-intercept when we are working with an equation or graph. We use the term initial value when we're working with real-world scenarios. Please use these problems that were done for you tonight to solve the rest of your homework, and remember, the key to success in math is not only working hard, but working smart.